Right. Hey guys, welcome to the Azure Power Lunch for May 7th, 2021. My name is Prithvi Reddy, and today I'll be talking about SFTP and some of the common patterns we've seen customers use. One sec. Can you all see my screen? Okay.
Yep.
Yes.
Okay. Make this bigger. So today we're going to go into an SFTP and AKS deep dive. Again, my name is Prithvi Reddy, I'm a Cloud Solutions Architect. This is the basic agenda. What are some file transfer requirements that most customers are seeing? What are some basic target state architectures for transferring files from Azure back to external vendors, transferring files from on-prem to Azure, and then the last, transferring files from the public internet. So one is Azure out, on-prem to Azure, and then from the internet into Azure. Those are the three main architectures. And then the demo, there's a lot of information there, but I do have a GitHub page. We may not be able to cover all of it. Walk through that afterwards. So when we talk about file transfer requirements, if you look at this diagram here on the top right-hand corner, the legacy model was you had all these application servers. Maybe application 1 was marketing, application 2 may have been finance, and if the finance team needed to pull files from, imagine this VM over here was finance and this VM over here was marketing, and if the finance team wanted to pull a file from marketing, they had to set up an SFTP server, and then the application on the left-hand side had to push files to that server. And this, as you can see, all these lines here, it causes a big mess of data traffic, right? Because now every single client or dependent app of this main marketing application or data has to set up an SFTP server. So it becomes very much, I mean, this topology makes a lot of sense in an on-prem data center, because the idea was that you could cache the data closer to the dependent apps, and then the dependent apps were responsible for pulling the file. Basically the primary app was responsible for pushing the apps to the dependent apps. But it's not very efficient, right? If you could go on mute if you're not speaking, that's okay. So as we move to cloud architectures, you see the diagram here on the right. We want to move to a model where the dependent apps are pulling the files from a central location. So instead of each of these apps having an SFTP server on it, the apps would all pull from, for example, an Azure file share. And if there's on-prem data that needs to be sent, all these on-prem apps would send it to a centralized file sync appliance or an SFTP server. And then this SFTP server would have mount points to all these Azure file shares. And then the dependent apps would have their specific mount points to pull whatever data they need. So essentially the big benefits of all this is, number one, you don't need to install SFTP server on all your dependent applications. You're centralizing your file transfers. And this segmentation achieves three things. You improve security, management, scalability, and you reduce your overhead. What does that mean? I know it may be pretty obvious in the diagram, but how do we improve security? So if you see this, where every dependent app is pulling from the source, there's a lot of data flow going on here. So by moving to this model, you reduce the amount of data flow and points that you need to control. Management, this is pretty obvious. Instead of having to install SFTP server on every single dependent app, you only have to install it on a single appliance. So no need to manage n instances. You're down to a single instance. Now you could make this single instance into a scale set, so it's redundant and scalable and all that. So it scales up and down based on your SFTP demands. Because you're probably wondering, hey, this makes it a single point of failure. Yeah, you're removing all the management overhead, but we can solve that by adding some resiliency on the appliance itself. So one of the big things customers migrating to Azure have a dependency on SFTP because we need to securely transfer the data from on-prem to Azure. No matter how much you put in Azure, there are a lot of data sources still on-prem. Also, one of the big requirements in many companies is non-secure FTP is prohibited, because if you just do a regular FTP that's clear over the wire, it's not very secure, it doesn't have SSH keys and all of that. And especially if you work in the banking industry or financials or telecom, the data must also remain on a private network, meaning when this data comes from on-prem, we want all of that to go privately. So we want to be able to use private link, which we'll get into more details about in the next slide. The keys must be secured, meaning that any of these clients that's pushing data to these to this appliance should have the authorized keys to do so, or otherwise they're not able to. And then the appliance must be capable of reading that SFTP protocol. Any questions on this? On why this is the legacy model and what we're moving to in Azure? Okay. Move on to the next slide. So we'll go into some different use cases. The first use case is moving files from Azure to an external vendor, and we see a lot of customers have this requirement. And I'll walk through a quick data flow. So the scenario is pretty simple. I've got a file in Azure, and I need to send it out to an external vendor who's outside of my network. So this is just a flow diagram. So the application host, which is your let's say this is the finance application, through a private endpoint, it's mounted to an Azure storage account. Again, based on the previous slide, the requirements are you don't want storage accounts out on the public internet, because that means that if someone happens to get access to it, they have your data. So by using a private endpoint, all the data is secured privately. So this application may be writing some data to the storage account. So that's step one. Now you need to send some files out to an external vendor. So step three, as we mentioned previously, we want to centralize all the file transfers through an appliance. So you can set up a VM, or when we get to the demo portion, I've done it inside of a container. You can run SFTP inside of you can set up an SFTP server essentially. And so now that's step three. Then this appliance needs to be able to send this data out to the external world. So this will go through a PLS, which goes through a PE, and then the PE, the private endpoint can point at the resource on the far end. So in this case, actually, the appliance is the client because it's sending the file, and the vendor is the SFTP server. So you're creating a private endpoint to the external vendor's SFTP server. Any questions here? So the impact is low because you just have to mount this Azure file share. And then from a coding perspective, if on-prem you were using a file share location, the only change you just have to change your mount points to point at this file share rather than some mount point you had on premise. The external impact is also low. The vendor has to allow the inbound connection coming from your private endpoint in Azure. And there is some key management involved because you have to, this client's authorized key has to be allowed on the vendor side. Any questions here? So this is probably more of what you'll be facing when you're going through a data migration, is how do you copy data from on-prem to Azure, or copy data from an external vendor into Azure. So this flow is, the previous flow was outbound, sending data out of Azure to the vendor. Here is the data, sending data from on-prem or external vendors into Azure. So same thing, but a little reversed. So the external vendor is initiating the connection, or the on-prem client is initiating the connection. So think of these as your SFTP clients. So step one, typically teams have a jump box in their Bastion network, and then that endpoint points to like a jump box server. And then from that jump box server, you could, the reason why we need this jump box is in order to be able to access this SFTP server, we need to retrieve the key, right? The authorized key to this SFTP server. So typically in Azure, what we suggest customers to use is Azure Key Vault. So the only purpose of this jump server is, and this is not something that the external vendor or on-prem user has to do all the time, because this is a one-time thing. You're going to retrieve the authorized key, store it in your known host or authorized key file in SSH. If you're a Linux user, if you're a Windows user, it's a little bit different. But still, if you're going to use SFTP, you need your keys. So does that make sense? Jump box has access to Key Vault. Key Vault, you get your key. Then step 3, you're going to create an ingress. Whereas in the previous step, we created a private endpoint from Azure to the vendor. In this case, the vendor is the client. They're going to reach into this private endpoint within Azure. The private endpoint bonds together with the private link service, and the private link service is connected to the actual appliance. That's your SFTP SFTP container or server running inside of a VM. This SFTP server is mounting the file share, the same file share that the application is using. So the vendor could drop a file into here, it automatically gets added to the file share, and then my application can then use it. So the nice thing about this solution is that if there are other dependent apps, I've only shown one VM in this diagram, but let's say that there's other departments like IT or sourcing or other departments within your organization that also need to use that file. All they have to do is mount that file share. They are no longer responsible, or this vendor is no longer responsible for sending it to n number of targets. Does that make sense to everybody? The end goal the problem we're solving. So we're centralizing that. Okay.
But a quick question. So is getting stored on 2 places, from external to the file share appliance, and then it goes to the Azure storage, or?
No, actually, so both the SFTP server and your dependent application are mounting the same file share. So this appliance is mounting this file share, and the application is also mounting the file share. So this appliance could write a file called, May 6th transfer, right? And since it's a mounted file system, the external vendor has written a file to that called May 6th transfer. Now the application has the same file system mounted, so it can see that May 6th transfer. Does that answer your question? So, but another application may also mount the same file share and see that. So we're not writing the data twice. We're only writing the data once, and all these dependent applications are reading that same data from the same share.
Okay, got it. Thanks.
The idea here is that since this is a centralized appliance, there may be more than one file share mounted to the centralized appliance, because let's say this is like a shared service within your organization and it supports all the transfers coming in. So you may have data or different file shares for finance department, IT department, sourcing department, all mounted here, right? But on the application server over here, you would only have the file share that's relevant for you. Does that help answer your question? So the vendor write a file to the IT file share, and then the IT application could mount the IT file share and read that data. And they don't have they don't have to worry about transferring files or setting up SFTP server on their VM. You could think of this as like a centralized IT operation, and your app guys can focus on development, things like that. Hope that makes sense.
Because do you recommend to have a service principal in order to give access to an external partner, or how does that work?
Yeah, so that's a good question. That's why we're using a key that's stored in Key Vault. And so this was really the first step. So we can't use a service principal because this external vendor may not have access to Azure, your Azure subscription and things like that, right? Depending on your agreements, they may have access to your Azure subscription, and maybe you're okay with vendors. But in the scenarios, at least that I've dealt with, they do not have access to Azure. So in that scenario, we just put a simple authorized key in Key Vault, and then gave that authorized key to the vendor, so that they can only use that key to do SFTP. They can't use that key to SSH even. Any additional questions there?
Can you use third-party key vaults? You
can. I mean, this is just Azure Key Vault was just an example here. If you use some third-party key vaults, like which ones were you thinking? HashiCorp or something?
Yeah, HashiCorp.
Yeah. Yeah, that's fine. I mean, as long as you have a mechanism to retrieve the key and then store that SSH key locally on either the vendor's client machine or the on-prem client machine, that's the first step in the whole process, right? Once you have your keys, your public-private key pairs set up, then you should be able to transfer files to your appliance. Any more questions here? Okay. So last but not least, so this is similar to the previous example that we gave, but we found that many vendors do not have so this scenario right here where the external vendor is able to connect to the private endpoint, this would only work or an on-prem network, if the external vendor actually had like an express route circuit or something where they can where their network and your Azure network are you can connect via private connections. But the scenario we see a lot is that the customers don't have that, right? The external vendor is in a separate network, and Azure is in a separate network. In that scenario, you can't use private endpoints, right? Because it's not routable through a private network because you don't have an express route circuit or that connectivity. This is probably the more common pattern that we see, is that the external vendor connects to a public IP within Azure, and that public IP is protected using an Azure firewall. So the Azure firewall will have rules on it that say, basically does a sanity check to say, okay, whoever's coming in to my environment, do I trust them? If they don't, then drop that traffic, right? So you would have allow rules on your firewall to say, yeah, only allow from specific sources, right? And then once the firewall says, yes, I trust this person sending me this file, then step 3 is very similar to the steps we saw in the other scenarios. The file will get sent to your SFTP server. The SFTP server, as usual, will have a Azure file share mounted to it. And then you may have, and this example has both AKS and a VM. So now you can mount a file share not only in a Kubernetes container, but you can also mount it within a VM. Any questions? Okay. So let me go through my GitHub page. Okay. So I have a GitHub page that walks through the setup of this on a Kubernetes cluster. So we're going to set up a SFTP pod, which basically serves as the SFTP appliance within AKS. So the steps are outlined here. But essentially, like I mentioned, you would create a namespace, kubectl create namespace SFTP. And this part about the keys is important. So you would generate, you would copy your public key. So I meaning the client, you're the person sending the file to the server. So in this case, let's just imagine step 2 is the external vendor, and they want to send a file to your to a pod inside of AKS. The first step would be that the vendor would create an RSA.pub file, and we would create a folder called client keys, because that's the vendor's keys, right? And we would add those RSA pub files into the local config. Then the second step is you have to create host keys for the SFTP server. So the command that people typically use is SSH keygen. So this will create the key on the SFTP server. So these are typically referred to as host keys. The public key is typically referred to as the client key. Then inside of Kubernetes or AKS, you will create a secret for the client keys. So it's essentially this command right here. You'll create a secret from the client keys. These are your public keys, and then you'll create a secret from your host keys. So this is the kubectl command. If you guys are familiar with AKS, this is how you create your secrets on your AKS cluster. Once you're done with that, you would apply this manifest to run your SFTP pod. So what this manifest is doing right here, if you take a look at it, it's creating a namespace called SFTP. It's going to create a service called SFTP. In this scenario, the service is being exposed on a public load balancer. And this is just something that is a good best practice when you're using SFTP. You don't want to expose 22 out to the internet, because 22 is a port that gets hacked quite a bit, right? Any of your security guys know that. So you want to change it to a less well-known port. So the nice thing about Azure Load Balancer, any load balancer for that matter, they do natting, so the front-end port can be different than the back-end port that SFTP actually uses. So you could, in this scenario, I put 23 for the example, but this could be 5001 or 8000, whatever front-end port you want for that file transfer, but it'll get translated to the actual port on the pod, which is 22. This section is actually just the deployment. How many pods do you want? So as I mentioned earlier, since you're centralizing the service, you may want to have more than one pod, right, for resiliency. You could also turn on horizontal pod autoscaler, which is a feature within AKS, which automatically scales up and down the number of replicas you have based on demand. So for example, maybe you have a lot of file transfers at night. You may need more SFTP servers to handle the load. So you could turn on pod scaler instead of setting a fixed replica count here. So pretty basic stuff. This is where we mount the, if you're familiar with volumes in AKS, we mount the public keys and the host keys. So here are the public keys from your client, which is could be your external vendor or your on-prem user. We defined secrets earlier in the steps. Now here's the key piece, the question that was asked, like, okay, so the data is mounted to an Azure file share. How do we mount that Azure file share to my pod? The way we do that in AKS is we use this term called a persistent volume claim. Persistent volume claim is just mounting the file share to the pod. So that's how you specify that. And you can specify in your YAML file how big you want your file share. So in this case, the persistent volume claim is a 5 gig file share. And then here's the permissions, 777, so they can do anything on that file share. So that's how you mount the file share to the container. Now keep in mind, this is just a container example. You can do the same thing on a VM. You can mount a file share to a VM and make that your SFTP server. Using the default Atmos image, this is really popular in the industry for SFTP. You do have to set a username and password. So in this case, I've set a username and password of Azure user. Container port is 22. And so all those keys get mounted to different portions of the container. And that's it. So let me just show you something. So here's let me go back here, go to the screen. So kubectl get nodes, this will give you, so in this scenario, I just have a very simple AKS cluster with one node running on it. If I want to see the actual pod that got deployed, we can run a exec to the SFTP pod. So first we'll do a kubectl get pods. So there's one, this SFTP pod was deployed from that YAML file that I was showing from the GitHub site. Now you also want to be able to get what is the external IP address that was allocated to this pod. So you can do a get service SFTP-n. So the external IP here is 20.72.98.119, right? And the name of the user is Azure user right there. So if I wanted to SFTP to this, I could do SFTP-P on the 23 port. I want to go to Azure user. And just this is a scenario where I'm just a random user on the internet and I found this IP address. But by default, your firewall should block this, right? But in this case, I'm going to give the simple example. If I try to do SFTP, it's allowed, right? But it's still prompting me for a password. So if I don't want this VM to be able to access this this SFTP server, I can lock that down using an Azure firewall. And the way we do that, what are we doing on time? Oh, we're right at time. So in any case, the two components we didn't get to today are, in this case, we were able to reach the VM, but we were not able to authenticate because the client VM did not have authorized keys. And then the next step, I know we're out of time, was I was going to show you Azure Firewall, and you can lock down who can access this IP address through your Azure Firewall. Hopefully this was helpful. I know these sessions are short, so we can't go into too much detail. Any questions? But feel free to use check out my GitHub page. It's got all the instructions that I went over for setting up an SFTP server. And if you have any questions, feel free to reach out to me.
Prithvi, while you're on the call, I have a quick question.
Mhm.